first talk of the morning, so double thanks for that. And this talk is about DevSecOps Mythbusters. No? So the idea of this talk is to try to summarize all the things that, at least for me or in my experience, means DevSecOps, not just the few things that many people think about. There's a few tools in a pipeline and we are done. No, there's much more than that, okay? Obviously, that does not mean that CI/CD is not important. It is, and it's usually the first step, but it's not the only part of the journey. So we will cover that here. I've done this talk before, but this one is special because this is the open source edition, okay? So, of course, there are many more tools, there are many more platforms, but when I'm going to show example, etc., I'm going to just focus on open source tools, okay? So if you say, hey, there is another, yes, for sure, but okay, just trying to focus on open source because this is open source code, okay? So a bit about me. I'm Jorge Hidalgo. I work here in Malaga in Accenture. I'm a director of software engineering, and I'm leading our global Java community of practice, and also leading DevOps and architecture here in Spain. I'm a co-organizer of Malaga Jug, Malaga Scala developers and BokerOnSec groups. So community matters, for sure. And I'm also part of the OpenSouthCode organizing team with my black t-shirt. Okay? So if you, for example, this year want to earn a black t-shirt, so you know, it's easy. Okay, let's go ahead. So to start, I always want to put this, because for me, when I hear about DevSecOps, DevSQAOps, DevSecOps, for me, really honestly, it's redundant. DevSecOps is DevOps, because the opposite means that you are not having any security or any quality, so you are not really doing continuous delivery. You are just automating your deployments. So for me, okay, just to start, DevSecOps for me is a redundant term, but we need to play with the rules and we need to sometimes go into that term just to be sure that we are being understood by others, okay? And the point, trying to explain is that when we elaborate what is DevOps and we do this imaginary exercise when we have this wall of disillusionment and we just say, okay, DevOps working together, if we don't include security or other practices, what we are saying, we're just moving the wall to another place. So we not really go to the root cause of the problems that DevOps try to solve, no? So devs want change, they want throughput. Ops want stability, they want to have things under control, but what does security want? They really want the same, okay? They are not just some dark, well, with the light you cannot see it well, but you know, this typical stereotype of the hacker in a dark room with a hoodie, because who knows, no? So let's not promote the stereotype. Really, the security wants exactly the same that Dev or Ops wants, no? So luminous beings are we, as Master Yoda will say. So yes, this is about Mythbusters. This is about trying to destroy some preconception about what is DevSecOps. And at the end of the day, and this is a very nice, adapted from a very nice drawing from Bert Sutter from Red Hat, because we are all DevOps. We are all part of the same team. No matter if I am a database administrator or I am security, the moment that I try to adopt DevOps practices, I'm part of the just one team that exists, okay? We don't move the wall to another part. Don't just put the blame on someone else. We are all part of the same team. And just to finish this short introduction, I'm really a fan of comics, especially of Marvel Comics, okay? Don't want to start any frameworks, but really, DevOps or DevSecOps was invented by Spider-Man, no? In the first issue of Spider-Man, when Uncle Ben dies because Spider-Man did not trap the burglar that was in the place. So the Spider-Man was doing just, you know, fancy shows and things like that, no? And there was someone tried to rob, and Spider-Man, I don't care, it's not my business. And he just let this burglar go. And it was actually the person that then killed Uncle Ben. And this moment of realization on this the last page of the issue, no? If I could have done something, my Uncle Ben will still be alive, no? And comes with great power comes great responsibility. And this is, at the end, DevOps, or DevSecOps, or DevSQAOps, or however do you want to name it, okay? So remember always this, Spider-Man was the first to invent this, okay? So at the end of the day, DevSecOps is not different to the overall DevOps practice and principles. We speak about taking decisions, we speak about taking ownership of those decisions, measure and improve continually what we are doing. So specifically, don't try to be perfect the first time, because this is impossible. Do something, even if it is partial, then learn from that and improve continuously. And never assume, like a Spider-Man did once, never assume that someone else will take care of that for you. And we are going to cover what is DevSecOps in 5 areas. So we will speak about infrastructure and platform. We are going to speak about data protection, about identity and access management, of course, application security and pipelines, okay? This is also part of the work that we need to do. And finally, about quality gates, okay? So let's go ahead with infrastructure and platform. So when we speak about infrastructure and platform security and how these connect with DevSecOps, this means that all these kind of things that many times look like they are an afterthought, they also need to be done in this shift left motion, okay? So hardening should be done at the beginning of the project and continuously improve. Periodic patch upgrade cycles, we should be doing that since the beginning of the project. We need to be very aware since the beginning of the project of the end of life. I have one example on a client right now. They are putting in production something with a Spring Boot 2.7, which is almost going to be end of life. So yes, you took a very good decision of adopting a framework and a library at some point in time, but if you don't iterate that decision going forward in your project, you go to production and you think, oh, what I've done. So this also needs to be done continuously. So again, part of the DevSecOps principles. Of course, vulnerability detection powered by tools, because manually it will be impossible to do it. We many times think of this, for example, the CVE vulnerabilities when we're speaking about an open source library that I'm using in my project, etc. And we, many times, and I see that a lot, we forget about infrastructure and platform components. Like, for example, I could be patching my, let's say, JPA implementation in my project every week if needed, or even Log4j if needed, but forget that, for example, my MySQL database is vulnerable. I have not updated in months, okay? So infrastructure and platform need to be, have the same, let's say, level of observation and continuously monitoring that we will have with code, no? There is a special part which are cloud-native code vulnerabilities, and then we are going to show an example. When we are doing applications in cloud-native world and using, for example, a serverless platform or a cloud provider, we just tend to think that my code is there and I don't need to do anything, but it's not the case. We need also to be aware of what the cloud provider and the platform is giving to me as information, and also constantly patch that. And all these tools typically have an API, so you can also put that API in your pipeline. So my code is perfect, all my libraries are okay, I've patched everything, but I have a critical vulnerability because, for example, my S3 bucket is open to the public. So I will not go further in my pipeline because I have this as advisory for my project. Infrastructure as code, this is really hot right now. No, we are starting to get like my Terraform pipeline, my Terraform scripts. I'm using help to just deploy something. I'm just writing my own Docker files that I'm using some image base from someone else, and I don't care about them. I also need to pay attention to these things. Am I using, for example, a Debian image that has been properly patched? Or is this Debian image properly hardened? So this should also be part of our DevSecOps approach, and as much as possible, automated and put into our pipelines. And then zero-day vulnerabilities. Why zero-day? Because we may have our software perfectly patched, perfectly reviewed, all the tools say, okay, I put it in production, and the next day there is a zero-day vulnerability found. So what once was secure no longer is. So again, it should be part of our commitment as DevOps or DevSecOps to not just be, put a lot of effort into the deployment part and just forget of the run part. We also need to monitor continuously what's happening in production. New vulnerabilities appearing every day. And the moment that we find something, if it is really serious, we may even take the decision of remove a deployment or isolate the deployment and put it in an autistic way, so not communicate it with anyone. And this is also very important. And if the previous is forgotten many times, this is incredibly forgotten in many organizations. End user computing. So we put a lot of effort in our software, in our libraries, in our dependencies, even in our infrastructure, but we leave our end user computers completely forgotten. So yes, you can work with the computer that you have at home. I don't care, no? So this means allowing or not allowing the use of certain applications or access to certain systems from an unsupported or untrusted operating system. It should mean blocking access to your application from all browsers that have known vulnerabilities, so you cannot ensure that your application is not going to be abused. Maybe you give 2-3 versions of tolerance, especially browsers that are mostly every week producing patches, but you need to have that policy in mind. And your application needs to have this, not just as an afterthought, but by design. And the last one, I think, is probably the most obvious of the three, which is blocking the access, for example, from a root or compromised device, okay? So all these things are also part of DevSecOps as well. So CVE, I've mentioned that before. Who knows what is CVE? Raise the hand. Okay, only a few. So you have not raised your hand, and I know you know it. Okay, so for those that don't know it, CVE is probably the most known and used vulnerability database in the world, okay? Basically, we have this an open repository of known vulnerabilities indicating what software is impacted, which versions, what is the exploit, and what is the workaround of way of resolving. Sometimes we don't have a patch for something. This happens a lot with zero-day vulnerabilities. They're exploitable now. We not always have a patch right at that moment. So it's always very important to be aware of CVE, look at the workarounds. Probably I cannot patch it, but I can put some protection. For example, when we have the Log4j issue a 3 years ago, at the beginning there was not immediately a patch for that. But it was possible to put certain filters. For example, you have a WAF or other kind of firewall. You could put filters there and block the offending patterns. So yes, you may not have a patch, but you have a workaround. And all this is usually published in the CVE database. So if you don't know it, it's very important and very useful. So you can search for your software. So in this case, for example, I just issue a search for, I can't remember now. I can't remember right now what was the query, but you can query by the software, Log4j, Spring, Hibernate, whatever you use, and you have it. And although I put sometimes Java examples, it's not limited to Java, of course. Okay, so this is open to every software that is in the world, open or not open. More things, okay? So we've also been speaking about cloud-native security and container security. So how can I be sure that I'm not using a base image that is not properly patched or have vulnerabilities? So there are very good tools in the open source space for doing that. This is an example with Trivy. So you just put Trivy, for example, in your pipeline, and the same that you do static code analysis for your Java, your JavaScript, or your Python code, you do the static analysis in your Docker files and other kind of files. And identify things like you can see, okay, you are using this package, or you are using this dependency. So Trivy is one that is very interesting. This one, if I remember right, is Clear Scanning. I put it, yes, this is Clear Scanning, okay? This is specifically focusing on base images. So you can see, for example, this report that says your image, okay, this is a synthetic example, no? But your image have 158 vulnerabilities, and then you have all the traceability. What are the things that you need to fix in your image? And then we will speak about quality gates. You can even stop the build if you found these things. Do not publish a container that have known vulnerabilities, especially if they are critical. But we also talk about cloud native, not just containers, but also configuration, a serverless platform, okay? So always be aware that the cloud providers will give you advice about what you have configured, and this should also be part of your DevSecOps approach, or even, as I mentioned before, through the API query and take decision on whether you continue or not deploying this. So this is a synthetic example with a lot of things, but you can, just for you to know, the many things that we can have here. So encryption at rest, encryption in transit, MFA, you don't have secure your management ports, etc., etc. Things that we tend just to forget because our code is secure. I just push it to Amazon or to Azure, no? It should be okay. No, it is not okay if we don't do these kind of things. Okay, so this one is an example from Azure. This is an example from AWS, for example, okay? And an important thing also, especially when you are trying to build, as I said before, responsibility in your teams for the things that you are doing, is to aggregate information from all these sources, because we are getting so much things from the different pieces that things start to get, dispersed. So there are very good tools also in the open source space, like DevDojo, that with a simple API allow me to get all measurements from all the different tools that I'm running. It could be in a nightly process, it could be as part of my pipeline. I mean, everything will find a way. But you then push everything to this tool. So we always have visibility, we have traceability, we can take ownership and responsibility of the things that we are doing, and also of the decisions that we take. For example, we know that we have a risk. We think that this is mitigated. This way, we are deciding to put this in production. And then we document in the DevDojo that, for example, this has been mitigated or won't fix or whatever. But last but not least, what happens in the real world? That, as I mentioned before, you find a new vulnerability, it's not patched. What do? Do you just take out all your software from production? So sometimes even we just find that we have a vulnerability that is probably not applicable to our software because we have special protection for a firewall, or if it is an intranet application. So not always what some of the tools tells us is something that I need to address. So always think that no matter how much automation do we have or how good our team is, no process or tool is perfect. So you need to always have, and this is very important in a DevSecOps mindset, first, identify and manage policy exceptions. Tools are important again, but at the end, as a team, we take decisions and responsibilities. So you need to have a way of identifying and managing policy exceptions. So they say, I am going to accept this risk and continue. And also to identify and manage false positives. So don't let your users down. Don't deploy in a chain which is important to production. Just because you have something, the tool says you cannot deploy, and you are looking into that and you say, this is really a false positive. It's not really applicable here, okay? So this should also be part of this. And before going forward, I wanted to take some rest because this really applies to everything else also, no? Not just to infrastructure platform. I am telling this here because it's the first one, but this should apply to everything. We find false positives when scanning our source code. We may find false positives when we are analyzing our data. So everything should be with this in mind. And especially as a team, as a DevOps team, remember, we are DevOps or DevSecOps. We don't have dependencies. We don't rely on anyone else. We cannot blame anyone else. We are just ourselves. So this should be something that we need to address from the beginning and be sure that it's part of the process, okay? Questions at this point? No? Some example tools. Falco is interesting for container scanning. Clear Scanner that we've also commented before. Trivi, we have TF-Lint, we have Chekhov. Chekhov is very interesting. It is doing a static code profiling of Terraform scripts. So things that you do in Terraform that probably are not good, or you are just using anti-patterns, you can find them with Chekhov. And as I mentioned before, DevDojo, that is very useful to aggregate and to have visibility on everything that we've been finding, what is critical, what is not, what is going to be fixed, what is not, etc. Okay? Next, data. Data is probably the most forgotten part of security in general, I will say, but DevSecOps in particular. We just focus a lot on applications. If we are more advanced, we start to do infrastructure and platform thing, and we feel good. But what about data? Data needs also to be part of this mindset. But it's different, okay? So we have different considerations in mind. First one is very obvious. Many people think, oh, data security, okay, encrypted. Everything is encrypted. I'm fine. And, okay, it's good, but this is just first step. What about data classification and the GDPR? Do we know of, for example, our database, which tables or which portions of a table, with column groups or whatever, have sensitive information? We are doing a healthcare application. Do we know in which portions of our application we have a service that consumes data that may expose personally identifiable information or health information? You will be surprised the many times that the teams do not know anything about that. Probably there is someone in the business that have this knowledge in the head, even documented in some functional documentation form. But many times, the developers, the engineers, don't know about that. Sometimes even don't care. So they are just doing APIs and just exposing the data in the database and not thinking about data classification. So data classification is important just to differentiate which data I need to have double care about it. And, well, okay, no spoilers, I will say later. Also very important, retention and deletion policies. Do we know our data, how long shall be retained in the system? It could be a change log in the database. It could be logs from our production application. Again, many times, the developers don't know or don't care about this aspect. They just expect that someone else will tell them or even fix them, no? Ops problem now. So again, this should be part of a DevSecOps mindset. The data access modeling. Even when we know exactly which portions of the database have sensible information, healthcare, personally identifiable information, credit information from a person, so things that are really, really sensitive, are we really ensuring that our application have the right access per the functional role? So for example, the user belongs to the marketing department, so this person can access this specific data. If it is not written, like as a specification, developers and engineers usually don't care. They just query data. Or a report, who can access this report? So all these things you need to, as I said before, I mean, I'm repeating this a lot, but we are DevSecOps teams. There is nobody else that is going to take care for that. We need to be sure that we have this in mind, that we do the right questions, and then create our code to be sure that it's working like that, okay? If we say that classification leads to compartment and isolation, no, because I know this data is the one that contains the sensitive data. So I know very well how to, let's say, monitor access to this database. When we are speaking about microservices-oriented architectures, this is very good because in a microservice world, it's really very good to fix that. No? If we have a microservice, I'm going to switch a bit forward. No? If we have not the monolith to the left, but we have a microservice-oriented application where each microservice is responsible for its domain, and as part of its domain is also the database, it starts to be very easy to be sure that nobody is making inappropriate use of important data, sensible data, classified data. Because we are exposing all data only through an API, and we can control very well with a lot of granularity which API expose important data and which not. This is incredibly difficult to monitor in a monolithic application. You have queries, joins, 5, 10 tables in the same query, then you have a view because it's cool, and it's start to expand from this monolithic way of thinking. Who is making use of this field, this column in this database that have, for example, the income of this employee? With microservices, it's usually much easier, no? In general, when you segment access to your data, when you also apply a role-based access control to data, It could be through the API, like I said in microservices, but it could be also implemented at a database level. It's always easier. But again, I mean, and this is also more complex the more data we have. For example, data lakes. This is usually a nightmare for compliance teams. We just put all company information in a data lake, and the world is great. I can just put my Power BI or whatever business intelligence application, ingest all this data, and do all kind of reports of all my application, and I'm happy. But are you sure that you're really using the data that you should be using? How do you control that? Okay. So again, microservices help for that, but it's not the only thing that we can do to help. One important thing, create test cases for all these kind of validations. So for example, I have my web application, I have my API application, I have Selenium scripts, I have SOAP UA scripts, for example, and I'm using Postman. Create test cases. Sorry about this. Create test cases to validate that. If, like this example, no, in BDD format, if as a user from the user resource group, when I'm logged into the application, I'm the one that have access to the employee payroll data, write a test case for that. So even if you, as a developer, make a mistake, because we all make mistakes, you have a test case that will ensure that this is not happening. This is an example of employee payroll data, but imaging, healthcare, whatever. So create test cases for all these validations that we mentioned before. Make that part of your acceptance and regression test. And as you have it then automated, run them with your CI/CD builds. If they are too many, you cannot run it in every check-in. Do it at least nightly, but you have a very good, let's say, safety net that allows you to ensure that your data is used appropriately. Okay? Questions about data? No? Okay, identities. This is also a favorite of mine, no? Because this is classically the typical thing that is someone else is taking care of that, no? We have a different team that is taking care of identity and access management. I just want a user that have access to everything. Okay? Okay, let's raise hands. Who has asked for an administrator user in the last week? Have requested that? No? Nobody? No? I have requested twice for a couple of environments. It's logical. We are developers. We need to do that. We are doing all the things. So CDcator for whatever. But I need an administrator access. But do we always need administrator access with all kind of permissions? So probably I'm just deploying Lambda. So a Lambda power user role will be more than enough. But we tend to just ask for administrator access. And if you can give me administrator access at the root level, great. Because at that moment, I can authorize everyone in the project. No? Okay, yes, that's part of the story, because again, if we are working on a DevOps world, or DevSecOps world, we are the only team there. So we need to also take care of our identity and access management. Sometimes there are some rules at the organizational level, so there are some foundational rules, but we give this, or we are given this responsibility. But this doesn't mean that we just give administrator access to everyone. Now we have the responsibility, now we need to take the decision, and we need to think, okay, probably Fran don't need administrator access for this. A power user Lambda role is more than enough, okay? So important, differentiate administrator for internal users. Important, apply multi-factor authentication to everything you do, okay? We found out kind of 2 years ago, quite painfully, that in a cloud provider that I will maintain in anonymity, the tokens that you get when you log into that cloud provider through the CLI had 2 years of expiration time. So you have your token, you may be out of the project, you may be out of the company, the token is still valid, okay? So MFA is always a great addition when you have tokens and you need to reapply them more periodically, because the moment that a person leaves the team or leaves the company, usually the MFA access is revoked. So it's very easy. When you have a token which is valid, the MFA will not allow you to continue doing these kind of things. Another important thing that, again, we just are used to rely on someone else and then we don't care is privileged access management, which means that nobody have access to administration roles by default. But when someone in the team needs that, we don't need to, usually we have a pressure, we have a deadline, we cannot raise a ticket, wait for someone. PAM tools are very useful because someone in the team may ask for these administrative permissions, and other person from the team will authorize that. This always means that two people in the team will know that someone has administrative rights for some period of time for doing, of course, typically appropriate things. But it's very difficult to abuse of a system in that way because you are not on your own to have administrative privilege. Think of that like a sudo prompt when someone else needs to come to your computer and do the sudo password for you, but in a more elegant and also with no external dependencies. So nobody has administration rights, but everybody can ask for administration rights anytime to do something legitimate in our system. Of course, machine-to-machine access, usually called application IDs, and with different twists. So for example, we are now working on a project with workload identities, and I'm really liking that a lot because this means that we no longer have secrets and tokens and other kind of security information going there from system to system. Authorization is done with machine identifications. So for example, this pod is authorized to do something. This pod is not authorized to do something. But you don't have tokens, something that with administrative rights, for example, can go into the system, can look into that, can get that token, and once they have the token, they can use it everywhere. There are no tokens. There are no floating things there. So very interesting mechanism, not just the typical application ID, which is just your user or my user, but it's just for an application. Maybe password never expired because, okay, I cannot update my Jenkins passwords every week. Okay. So machine-to-machine is very important, and there are new mechanisms that are very good, especially when we're working on a DevOps mindset, when we are just on our own, to be sure that there are no ways of exploiting that easily. Of course, certificate management, and if you can do it at scale before, we will see an example there later. And of course, role-based access control, having as lower level in granularity as possible. Actually, later in OpenSouthCode, there are going to be a workshop by Alejandro Escanero about security in Kubernetes from the ground up. So if you are interested in knowing more about this, there is a specific workshop when you're going to have a Kubernetes cluster, and then you can do nasty things or not, depending on how you configure the airbags there, okay? So certificate management. This is very easy when you have just a few dozens of machines, no? Remember the world in which we have our servers are cattle, and we just, as pets, and we just put names, no? We have a project when South Park was really hot. We have our servers, they were named Kenny, Carmen, etc. So we can always say Kenny has died because the server was down, okay? So we put names. I've been in projects where we put names to our servers. In that moment, it's very easy to just go to your CA authority, whatever, and just issue a request for updating your certificate. But what happens when you have hundreds of nodes, and each node may have dozens of pods? Then certificate management can be a real nightmare. You can say, okay, Jorge, no problem. We just do wildcard certificates. But wildcard certificates just open your doors, okay? So this may be easy, but sometimes may have an important drawback, which is you're opening probably too much. So there are, of course, better ways to do that. For example, Cert Manager, which is an open source certificate manager that you can put in your system, for example, works nice in every Kubernetes distribution, and other open authorities like Let's Encrypt. This allows you, in an automated way, to generate certificates and make renovation of your certificates for every component in your system. And you don't need to have one person manually creating new certificates or renewing certificates. So this is really great at scale. Another interesting thing, service meshes such as Istio, they also have mutual TLS bringing. So this means that you configure the policies, and Istio will take care that all the communication between the components of your application, so every pod in every node, whatever they are, every communication is secure, and nobody can, even with administrative access, can eavesdrop these communications. Just Istio abstract you from this complication. So what does it mean in practice? Imagine this, okay? We have this cluster, we have some manager nodes, we have some worker nodes, we have email registry, persistent storage, whatever. This is the physical layer. I don't know at this point each of these pods, each of these container, from which application is. This is the physical layer. But what I see just when I look at this is that this is unmanageable. I don't know all of these workloads, where they come from, which application they are, which department they are. So really, the way to address is not at this physical level, but more on the logical level. We usually use namespaces as a very natural way to compartment, to segregate our workloads in a cluster. We can give out namespace to a department, to an application. We can even separate namespaces for per environment, like the development namespace, the test namespace, etc. And when we say apply RBAC policies to this, it's easier because now it's the logical way. I don't care where this pod is running. I don't care if it is in this cluster, in the other cluster, in another region. I just care that a super admin may access to every namespace. An administrator of namespace C may have written access to the pods in that namespace C, but none have access to any other namespace. And this is the really appropriate way of doing that, not at the physical level. And then you can have things like that. So this is, well, light is not good. I will share the slides, or you can just go here and see it. But these, believe me, these are just some Terraform snippets. But are Terraform snippets in which we are defining this RBAC that we have been sampling before. And we say, OK, let's create these groups. Let's give these permissions, and then assign these permissions per role to the relevant namespace. So we do that, and the infrastructure as code is not an afterthought. It's part of the design. And, of course, as I mentioned before, then we write the tests to ensure that this is happening. Okay? But role-based access control is not enough to just done in the run level. Now we have a new world of exploits, which are supply chain attacks. So imagine if I have access not to your cluster, but to your image registry, and I can just replace your images with whatever I like for example, adding a backdoor, etc. So when we speak about RBAC, we also need to extend that to our container registry, or in general to the places where you are putting binaries. This means, for example, who can push, or who or what can push something into that container registry, or who or what can pull images from that container registry. And don't let an attacker with some privileged access to just tweak your images or just get an unsecure image run directly into your cluster. Because if they have access to that, they put the insecure image, they run into the cluster, and then they have access to many things just because they have an image. Imagine when this image has additionally root permissions. There are many images still with root access, even when they don't need to have root access. So this is really, really important because these supply chain attacks, especially infrastructure, are now running hot. Okay? And of course, extend that to secret management. Don't have just one vault for just your whole company, which means that everyone can go there and start doing things with the secrets. Okay? Also, do RBAC and compartment your secrets in your system. Okay? Again, who can create or update a secret? But more importantly, who can really get the secret? Because if not, an attacker with access to the cluster can just go into a pod, and once inside the pod, they can do click, click, click. With the CLI, I do that with Lens a lot. And I can request whatever secret there is in the vault. Unless I have this compartment, I can easily get any secret from the whole organization. For example, the production database secret. Because at some point, in some place, there should be the secret for the database production. Sorry, for the production database, because if not, the application will not be able to connect to that. Okay? So again, RBAC and compartment also extended to secrets. If this means to have 200K volts or whatever, that's good, okay? Because even if you have one compromise, you don't extend this vulnerability to the rest of the system. And of course, automate as much as possible. For example, one of the projects we're working on now, we have all these kind of RBACs, etc. Not only automated for the Terraform, for the infrastructure code, but also in the Terraform we have the part to do this for the registries and for the secret management. This can also be automated and written in your infrastructure as code, okay? So exemplar tools for that. We have Cert Manager, we have Let's Encrypt, we have Envoy, we have Linkerd, we have Istio, so these are examples of service mesh. Open Service Mesh, of course. We have Helm Secrets to manage secrets. We have Conjure to manage privilege access management. So these are all examples of open source tools. Of course, there are many more, but these are all open, so you can start using right now. And we are bad in time, so let's move a lot faster now. So applications, I'm going to be faster. I understand that this is already known ground for everybody, okay? This is usually where we start. We do a static code analysis for our code, we find vulnerabilities in the code, we do dynamic application analysis, and if you don't do, there is a nice talk later, okay, they should be preparing with Marta and Claudia about using OWASP SAP for dynamic application security testing. Of course, we do software composition analysis because I care about which libraries I'm using in my code. And also, not so use, protect your code for exposing secrets or sensitive configuration. No? For example, Git leaks is a very simple tool that you put in your pipeline and will help you ensure that you have any secret in your code. Very simple to configure tools. You can detect a lot of things. I'm not going to start here, no? SQL injections, file path injections, many different kind of things. These tools are really nice for that. Example tools. Okay, so this is not the marketing division. Okay, we have them the marketing division, but SonarQube is very nice example. Okay, you will explain much better than me about SonarQube, but it's open source. We can start using it anytime, and sometimes people tell me, well, but this is not the best tool for security, but it has a lot of things already, especially if you configure the Find Checkbox plugin. Then you have literally hundreds of rules to ensure that your code is nice. This is a WhatsApp, okay, for doing both passive and active dynamic application security testing. As I mentioned before, we have a later here in a talk in the conference about that specifically. And in general, when we speak about our CI/CD pipeline, which is full of tools, full of things here, we don't forget that we should be doing the code inspection part, we should be doing the software composition analysis part, and as part of our integration test, it's very easy to just have our passive dynamic application security testing, okay? Of course, this is not a full penetration testing, but it's quite good. It's going to give us some useful insights about what's happening there, okay? Well, and this is how it looks when everything's green, and we just push our changes into production. Example tools, as I mentioned before, we have SonarQube, we have Spotbugs, we have Find Checkbox, which is a complement of the Spotbugs that you can also put inside SonarQube. You have everything in one place. We have PMD, can also be used from SonarQube or independent. We have ESLint, we have PyLama for Python, we have Chekhov, also commented before. We have Nictro or WhatsApp for dynamic application security tests. We have Dependency Tracker also for identifying issues in our dependencies, and we have Detectify, that is also open source. Well, there is a commercial version, but there is also an open source community version that you can use. Questions about application? Who is doing application security testing in some way or another right now? Okay, there is hope. Okay, that's good. I mean, we are speaking a lot of things, but of course, doing static analysis in our CI/CD pipeline is also important, okay? Don't forget about that. And it's usually the first step because it's very simple to set up and give us a lot of information from the beginning. Okay, and just to finish, we have quality gates, okay? So quality gates at the end of the day is the way to ensure that all the things that we are doing really are passing or not based on our criteria. And we don't have the human looking at every bill, every time, look at many reports and decide. If we just program these thresholds into this concept of the quality gate, we can just have this also automated. So define your quality gates, but of course enforce them as part of your CI/CD process. And maybe you have a more relaxed quality gate for development, like you have just a quality gate which is informative, and then you just put pressure as you progress in your environments, and don't let, for example, put code in production that have a critical vulnerability. But even if you have different policies depending on which moment of the cycle you are working, you always have these gates defined. For infrastructure and platform, you also need to be very aware of which levels of, let's say, tolerance you have. As I mentioned before, you may have a new vulnerability right now, but don't have a fix. So what I do, I don't push any other chain to production. So define things like, for example, for non-critical vulnerabilities, you give 30 days to fix them, 2 days for a 0 day. You need to, at some point, accept some risk, because if not, you may find that you're blocked for pushing a needed change in production. But of course, do not allow deployments when this threshold, this tolerance has exceeded, okay? As I mentioned before, you need to take a decision. Again, we are DevOps. There are nobody else taking a decision for us. So what's happened when we found something that is already in production is vulnerable? Then we need to take a decision. Is a risk that I can assume? Is there a workaround? If not, I may need to take these hard decisions. Remove my deployments. I cannot really afford to have an application with health sensitive information exposed with a really big vulnerability. So if I cannot fix it, if I cannot prevent it, maybe I need to remove the deployment. And it's going to be the DevOps team that makes this decision, okay? Okay, I'm going to just jump the FAQ. If you have questions about how to do this in practice, I can share, okay? One thing that I wanted to say before finishing is that always externalize your quality gates. So this is good to have your quality gates as part of the pipeline, but it's much better if you have your quality gates, for example, in a YAML file, and then you just use these values in your pipeline. Why? When you have 3,000 lines of code in your pipeline or in your Terraform script, a quality gate can just get these guys there. And then you get, for example, a pull request with 20 changes, and you don't realize that someone is maybe on purpose, maybe an attacker is changing the quality gate. You cannot see that clearly because it's just there diluted in thousands of lines of code. So when you externalize your quality gates and put them in a separate YAML file, it's very easy to trace that back. It's transparent. When someone makes a pull request that modifies the quality gate, why? Okay? So it's a best practice to separate, to externalize your quality gates. Or rely on a tool. This is, again, an example from SonarQube. You can define your quality gate in SonarQube, of course, for the things that SonarQube is aware. Okay, so it may not be the complete solution, but if you are looking at things that SonarQube is looking for you, like code smells, like security vulnerabilities, like complexity, whatever other metric that you can have in unit test code coverage, whatever, you can just rely on the tool to tell you if the quality gate passed or not. And then you can write that in your pipeline, because specifically with SonarQube or with Octane, with other tools, you can just query the tool. Okay, what happened after the analysis? Did I pass the quality gate or not? Okay? But whatever, you can use a tool, you can just write your own quality gates in the pipeline, do that, okay? Define quality gates and enforce them as part of the build. And with that, any further question that you may have? No? If not at this point, or you are very shy, okay. Jonathan, go.
Yeah, so going back to the part that you were mentioning about secrets.
Mm-hmm.
So secrets, in fact, are only base 64 coded, so it's clear secrets in a cluster. Why we all insist on using them to store important information when we should, well, you said we can create role-based access control to handle that, but shouldn't we use external services like Vault or other services to store that instead of using secrets?
Typically, this is the best practice. Now, the question, just for the recording, is whether we should be using external tools or platforms to store our secrets in which just using like a config map and put all our secrets there. No? Yes, okay, the point is that as a best practice, we should be relying on external tools for that, make all the necessary granularity, compartment, etc. Because a config map is very easy to see. Whatever with admin rights to the cluster can see any config map in any part of the cluster. So you have there all your production databases, everything, okay? So yes, the most that you isolate out there is good. Config maps are the dark side of secrets because they are easy, they are fast, and forever will govern your destiny. So don't use config maps, at least for sensitive information, okay? Any other question? No? Okay, go ahead.
One last question. Have you noticed that, well, with the development of artificial intelligence, tools like cloud custodians or things like that just research or look at your infrastructure, just looking for vulnerabilities and this stuff? Have you noticed that this is something that is happening with that, or is it evolving in a way?
But do you mean when you are doing an AI application or an AI tool looking at what you are doing?
Tool looking at your infrastructure, just looking for
Okay.
vulnerabilities.
My own experience is that there are still early stages of that, okay? Not still very good. Even they are really doing a very bad job in just writing, for example, Terraform code. It's very free. And we have the recent experience, no? But when we think of the evolution, we see, for example, that GPT right now is, or Copilot are very good in doing things that you have a lot of, let's say, massive code to train. Like, for example, Angular stuff, Java stuff is already doing really nice things. We can say, okay, with Terraform, with Helm, with other cloud-native things, we don't have as much code to train the tool. So probably that's why they are still not so good in DAST. But, you know, 1 year, and this is evolving so far, so let's wait. So later in the year when you have GPT-4 out for the while, what we can see. No? But if I just extrapolate from 2 years to now, what we are seeing with Java, with JavaScript code, and I extrapolate that to also infrastructure, etc., I would say that not now, but probably in 1 to 2 years, we will have a good tool to help us to do things. Right now, just to give a Terraform that compiles is quite tough. Any other question? No? Okay, if you find any other question, I'm going to be here around the 2 days because I have the black chair, of course. So thank you very much for being here.